I want to talk to you about the law of conservation of mass, which is a very important scientific law that states that matter, or atoms, are not created or destroyed in chemical reactions. And so you can see here we have some nitrogen, hydrogen, and they make ammonia. And the idea today is that we're going to learn that we have to have the same number of atoms before a reaction starts as after it concludes. So there's some rules to balance chemical equations to help us to accurately reflect the reality of chemical reactions. And the first rule is that you can't change the molecules. They are what they are. This is the reality. We're just learning how to see what reality is. The second thing is that you've got to stay on your own side of the arrow. So you can't put molecules on the reactants or product side if they didn't start there. And the final thing is that you're going to just add molecules to the correct sides until you get the number of atoms of each type of atom balanced. So here we have an equation, and we can see to start out with that we have 2 chlorines on the left and 1 on the right. That's not okay. We need 2 on the right. But we can't just add a chlorine atom. We have to add a KCl. When we do, our potassiums get unbalanced. So we have to put a K on the other side, which means that we have the right number of everything on each side. We've got 2 potassium iodides and 1 chlorine molecule give us 2 potassium chlorides and 1 iodine molecule. The total number of each atom on each side is the same, and the coefficients that we write in front of the formulas tell us how many of each molecule is needed for the reaction to take place. So here is sulfur and oxygen give us sulfur trioxide. We've got reactants are present before the reaction on the left side of the arrow, and products are present after the reaction on the right side. And so when we look at these, a lot of times we think that they're present at the same period of time, but they're not. This is not what happens. What happens is that 2 sulfurs come along and pull apart 3 oxygen molecules, O2s. And at the end then, what we are left with is 3 sulfur trioxides. Hooray! So this is really what happens in the chemical reaction. And when we write our balanced equation, it's just reflecting the reality. Again, KCl3, KCl, and O2 do not all exist at the same time in the reaction. 2 potassium chlorates react and rearrange their molecules into 3 oxygen molecules and 2 potassium chloride molecules. And so when we write those coefficients, it's just showing us the reality of what took place. The balancing of the chemical equations helps us to write them to reflect how the atoms really behave in chemical reactions. So we're not making anything up. We're just reflecting the true reality of what happened. So here's a few more examples. If you're good, you're probably going to stop watching anyway, but just in case you need more. So there's 2 oxygens on the left. I need 2 on the right, but the only thing I can add is an H2O molecule. When I do that, the hydrogens are all out of whack. But when I add another HCl, now I can see everything is balanced. I have the same number of each atom on the left as the right. 2 calciums on the left, 2 calciums on the right, 2 chlorines on the left, 2 chlorines on the right, 2 oxygens on the left, 2 oxygens on the right, 4 hydrogens on the left, 4 hydrogens on the right. These ones are tricky, these polyatomic ions, when you first look at them. Because you're like, I don't want to count all of those. But the thing is that they stay hooked together. And so all we really are paying attention to here is that our potassiums and our hydrogens are out of balance. And when we put 3 hydrogen chlorides on the right and 3 potassium chlorides, on the left and 3 potassium chlorides on the right, it balances everything else. So 1 potassium phosphate reacts with 3 hydrogen chlorides, rearranges, and it makes 3 potassium chlorides and 1 hydrogen phosphate. It's actually a double displacement reaction. Switching partners, scandalous. So here again, we got that nitrate, right? So if there's 2 on the left, we need 2 on the right. It's going to unbalance our potassiums, so we'll put another potassium on the right. And then our iodines are balanced and our leads are balanced too. We have the same number of each atom on the left and the right. And so this tells us 2 potassium iodides and 1 lead nitrate all rearrange their atoms to become 2 potassium nitrates and 1 lead iodide. Couple coefficients and we're good to go. Hopefully these ones are getting a little less scary, these polyatomic ions. We have 3 sulfates on the right and only 1 on the left. So let's start by tripling our number of sulfates. Oh man, but now our calciums are out of whack. We also have 2 aluminums on the right and 1 on the left. So let's fix our aluminums. Man, 6 bromines. But if we do 3 calcium bromide molecules, now everything gets balanced. So we take one atom at a time and balance it. Sometimes we make the problem worse before it gets better, but then you just fix it on the other side and fix it on the other side. And you keep going until you get each atom balanced. Some of them are a little bit trickier than others, but